Hello children, welcome to Zero Panic Maths. So in today's session, let us continue our discussion on the end of chapter exercises. And in the previous session, we have discussed the theory behind these exercises and the problems 1 to 5 we have discussed in the previous session. If you have not watched that video, the link is given in the description. Please watch that video before you start watching this video. Okay. So in today's session, we will see the remaining problems uh, of the end of chapter exercises. Okay, now let us see. It is the problem number 6. So now it says, are the points, the coordinate points m minus 3 minus 4, a 0 0 and g 6 8 on the same straight line? Okay, so simple. Okay, now suggest a method to check this without plotting and joining the points. Now why they have mentioned this part, suggest a method to check this without plotting and joining the points? Because you see, when some coordinate points are given, as we have seen in the previous session, when some coordinate points are given, we can just mark those points on the 2D plane and join the lines. Thereby we can be able to know that whether all these three lines come on the straight line or not. Okay, but here in this problem they have specifically mentioned that we should not be plotting and joining the points to know whether these points are on the same line or not. Then what is the different method that we need to identify whether these 3 points are on the same line or not? Okay, now there is a hint that I've already written, that to check whether the given 3 points are the same line. Okay, same line means collinear. Okay, linear line is a straight line, collinear means coming on the same line. Okay, to identify the given 3 points are on the same line, we can compare the slopes of any two pair of points. Slopes. Okay, if the slopes are equal, then the points are collinear. Now before we apply this formula given to find out the slope between the 2 points x1 y1, okay, given is the slope is the difference in the y coordinates divided by the difference in the x coordinate, that is the slope. You should be knowing what is slope is. Okay, so the detail on the slope that you are going to get in the details in the next chapter only, but here I will simply explain you what is slope. Okay, slope actually defines, listen to me carefully, slope actually defines the stiffness of the line. Okay, now suppose there is a line like this. Okay, and it is x1 y1. Okay, it is x1 y1 and this is x2 y2. Okay, give me some time. It's a simple explanation of the slope. Now it defines the stiffness. Stiffness means with the change in the x coordinate value, what is the change in the y coordinate value? Identifying that is called as the slope. Okay, now suppose now from here onwards the value of x1 is getting increased horizontally. Okay, whereas the value of y got changed vertically. So this change divided by this change is actually called as slope. If that change is towards the positive sign, means if the line is like this and going towards the positive side, then the slope is called as positive. And if it is going in the negative side, instead of this, if it is coming towards the downside, you know that the coordinate system towards the downside is always negative. So in that case, if the line is coming towards down, then the slope is called as negative. Okay, so if there are points given x1 y1 x2 y2, and if there is a point here, then the slope of this will be equal to slope of this only. Okay, that is what is mathematical proof. So to identify whether this particular line A, suppose this is A, okay, and this is P and this is Q. Okay, now given the 2 points P and Q, to identify whether this point is on that line or not, we need to find out the slope between these 2 points and slope of these 2 points. And if that is equal, it means the change in y coordinate with the x coordinate change between these 2 points is equal to this, then we can say that this particular point is on the line that passes through the points P and Q. This is what the logic we are going to use it here. Okay, how does this formula comes, all that will be, you will be seeing it in the future classes. Okay, so now currently you should understand, to identify any two to find the slope of any 2 points, this is the formula: change in y coordinate value, that is y2 minus y1, divided by change in x coordinate value. Okay, so this much is sufficient for now. Okay, now this is about the theoretical explanation. Let us see how do we solve this problem. Okay, now this is the slope. Now what did I told? To identify whether A is on the same straight line between M and G, we have to find out the slope of MA and AG, and if that is equal, then we can say that these two are on the same. Understood? Okay, now let us find out the slope of MA. Okay, here slope of MA, slope of MA is equal to, it is y2 minus y1, that is y2. So in this case it is the first coordinate and this is the second coordinate. Okay, y2 is 0 and y1 is minus 4. Okay, so it is 0 minus of minus 4. Okay, divided by x2 is also 0, 0 minus of minus 3. Okay, so what is this? Minus of minus is 4 and minus of minus 3 is 3. 4 by 3. So slope of MA is 4 by 3. Similarly, let us find out the slope of A and G. Okay, and slope of AG is equal to, here in this case it is x to y2, so y2 is 8 minus 0. Okay, 8 minus 0, and x2 is 6, again 6 minus 0. Okay, so what is this? It is 8 by 6. 8 by 6 is 2 3s and 2 4s. So what exactly is this? This is also 4 by 3. So it means that the slope of the first 2 points is equal to the slope of the second 2 points. It means that the line, the point A is on the line between MAG, or you can also say that all these 3 points MAG are on the same straight line. Okay, so we can write it here. Therefore, or else you can write, since slope of MA is equal to, slope of MA is equal to slope of AG, slope of AG. Therefore, therefore the points, you can say the points M, A and G are on the same straight line, on the same straight line. You need to write this it in detail. Okay, so this is the suggested method to check whether the 3 points are on the same straight line without plotting that by using a graph. Okay, understood this? Okay, let us quickly move to the next problem. Okay, now next problem is also based on the same only. Use your method from problem 6. So in problem 6 we have used the method of finding the slope. So same thing we need to use it here to check if the points R, B and C, okay, some coordinate points they have given, are on the same straight line. Again the same thing we need to find out, and now plot both the set of points and check your answers. Now they are saying we need to find out whether these 3 given points are on the same straight line by using the same method. Okay, let us find that, and finally they are asking us to plot this and check the answers for the verification. Okay, now let us first find out that. Okay, so here I can say slope of the first 2 points R and B. What is RB? It is y2 minus y1. What is y2? Okay, so first of all, it is slope of RB is equal to y2 minus y1. Okay, y2 is minus 5 minus of minus 1. Okay, divided by x2 minus x1. What is x2? X2 is minus 2 minus of minus 5. Okay, so what is this? It is minus 5 plus 1. Okay, that is minus 4. Correct? It is plus 1 minus 5. So again, this is plus 5 minus 2. Okay, minus 2 plus 5, it is 3. So it is minus 4 by 3. Okay, now find out the slope between the points B and C. Okay, slope of point BC. Slope of BC or slope BC, you can say. Okay, y2 minus y1. What is y2? Y2 is minus 12 and minus of minus 5. Minus 5. Y2 minus y1, and this is x2 minus x1. 4 minus of minus 2. 4 minus of minus 2. And what is this? It is plus 5 minus 12, which is minus 7. Correct? Yes. So it is 4 plus 2, which is 6. So it is minus 4 by 3 and minus 7 by 6. Now, since slope of RB, it is clear that slope of RB is not equal to slope of BC. Correct? Slope of B and C. Correct? Slope of BC. It is not equal. Therefore, the points R, B, and C, the points R, B, C are not on the same straight line. Are not on the same straight line. You can write that. Okay. Now this is the proof. Theoretical proof. Okay, so practically we can the second part is now we have to plot both the coordinates are given in the problem 6 and 7 and identify practically whether they fall on the same line or not. Okay, now I have a graph here. Let us identify the points and then plot them onto the graph. Okay, so what are the points? M, A, G are minus 3 minus 4, it is 0 0. MAG minus 3 minus 4 6 8. Okay, let me write those first here. Okay, M is minus 3 minus 4. Correct? A is 0 0. Okay, okay. Now let us identify these coordinate points onto this graph. Okay, okay, now it is there till minus 12. Okay, now let me write this. It is minus 10, minus 11, and minus 12. The last point it is. Okay, okay, now let me write minus 3 minus 4. First the coordinates of the first three points. Minus 3 minus 4. Minus 3 towards the x-axis and minus 4 towards the y-axis. It is minus 3 minus 4. It is M. Okay, the point M it is. Sorry, minus 3 minus 4, the point M. A is 0 0. Okay, we know this 0 0 and 6 8. G point 6 and 8. What is this? This is 6 and this is point 8. G 6 8. G 6 8. This is okay. Now let us first join this line. Let me take a line starting from M and join it like this. Okay, now this is the line and we know that from this line also we can say that A is on the line to M to G. Okay, line, the all M, A, G are on the same line itself. Now R, B, C, identify those. Minus 5 minus 1. Minus 5 minus 1 is, what is this point? This point is R. Okay, now again minus 2 minus 5. Minus 2 and minus 5. This is that point. R this is B. Okay, and finally 4, 12. 4 is on the x-axis, and then finally it is 12. 4, 12. So this is that point, I think. Correct? Is on the 4. Okay, 4 minus 12, and this point is 6. Now let me again take the straight line and join points R and the last one. Okay. Okay, take the shape. Okay, now you can see that when I joined the points R and C, you can see the point is falling a little bit down to this straight line, and it is not exactly on that line. As you can see, on the line between M and G, there is A that is exactly passing through that point. Okay, so practically also we have seen that it is not the RBC are not on the same straight line. Okay, so this is about the seventh problem. Okay, understood this? Okay, let us quickly move to the next problem. So using the origin as one vertex, plot the vertices of a right angled isosceles triangle. Okay, now suppose this is the graph given. There are two problems, sub problems in this. The first one is use origin as one of the vertex. So one of the vertex origin should be used as, and that is 0, 0. Plot the vertices of a right angled isosceles triangle. Okay, first thing is right angle means it should make a 90 degree in one of the angles, and then isosceles means the two sides, any two sides of that triangle should be equal to each other. Okay, so suppose if I take this as a right angle, because see both the x-axis and y-axis make the right angle here only, then I should be plotting that triangle as one side starting from here 1 to 3. Suppose I can take 1 to 3 also, or 1 to 4 also, and whatever value I take as this side, I should be taking this also as that side only, and just connect this. So this is that triangle. It is an isosceles triangle using vertex as one of the origin as one of the vertex, and making a right angle triangle there itself. So it is a right angled one, and since this is also the towards the x-axis also, suppose this is O and this is A and this is B. Now okay, now suppose I call it as AOB, triangle AOB, then in this case AO is equal to BO. So this side is equal to this side. So this is a isosceles triangle. This is a simple solution. You understood this? Okay. So it is a right angled isosceles triangle drawn by using origin as one of the vertex. Okay. Now let me write that here as shown in the graph. As shown in the graph. Uh, triangle AOB is the required right angled isosceles triangle. Okay, right angled isosceles triangle. Okay, where AO is equal to OB is equal to 3 and 3. So this is 3 unit, this is also 3 units. So both are equal. Okay, where AO is equal to OB is equal to 3 units. Okay, and angle AOB is equal to 90 degree. So this is what the solution for the first question of the eighth problem. You understood this? Okay, right angle isosceles triangle using vertex as one of the origin as one of the vertex. So the second part of this, there is a small difference here. There is a small difference here also. You are using origin as one of the vertex only, origin as one of the vertex only. You are going to plot a triangle, isosceles triangle, again an isosceles triangle only. Listen to me carefully. Isosceles triangle only, but with one vertex in quadrant 3. You see that one vertex in quadrant 3 and the other vertex in quadrant 4. It means that this is your, suppose this is O, okay, and this is 0 0. Now we have to draw a triangle in such a way that it becomes an isosceles triangle, and the other vertex, the second vertex will be in the third quadrant, and the third vertex will be in the fourth quadrant. Now how do I identify a point in the third quadrant and a point in the fourth quadrant so that those two lines or those two sides of the triangle becomes equal to each other? Okay, listen to me carefully. There is a y coordinate line that is going vertically down here. Okay, now assuming this line as one of the side of a right angle triangle, listen to me carefully. Okay, this, assume this as one of the side of the right angle triangle, and suppose if I am drawing a line with 3 here, okay, and with 4 points down. Okay, now this is that. Now this is a right angle triangle. Okay, so this is a right angle triangle, but this is not this triangle that is what is required. Okay, just listen to me carefully. First, what I am doing is, so this is 4 units down and 3 units to the right. You can get it. Okay, so this is 3 unit and this is 4 unit, and this is right angle. Understood? Okay, so if this is 4 and this is 3, 4 square plus 3 square is equal to this square, right? Okay, so it will be 4 square plus 3 square and square root of that. That will be 3 square, 9 plus 16, and 9 plus 16 is 25. Okay, square root of 25 is 5. So this will be 5. Understood this? So similarly, now if I am drawing another line here, okay, which is also the 4 unit down and 3 unit to the left, and identify one more point here, and similar triangle if I draw here, okay, here also it is 3 unit and this is 4 unit, so it is 16 plus 9 and this will be 5. It means that I have this side 5 and this side 5, and this is that triangle that is required. Understood this? Okay, so the triangle, isosceles triangle with one vertex in quadrant 3. What is that vertex? A. And one other vertex in quadrant 4. And what is that vertex? Is B. So the triangle OAB is one such triangle, isosceles triangle with quadrant 3 one vertex and quadrant 4 another vertex. You understood this? Okay, just ignore this line, but this is that OAB is that required triangle. Okay, okay, now let us write that as shown in the figure, or as shown in the graph. As shown in the graph, triangle OAB is the required isosceles triangle, right? Required isosceles triangle with what is that? OA is equal to OB, with OA is equal to OB is equal to 5 units. Okay, and if we want, we can even prove that OA and OB, the length of OA and OB is equal to 5 units by the formula given for finding out the length between the two coordinate points. Okay, now let us identify what are the coordinate points of A, because we have to show that A is in the third quadrant. Okay, so what is A's coordinate points here? 3 towards the x-axis and 4 minus 4 towards the y-axis. So it is -3 and -4. Okay. Similarly, what are the coordinates of B? It is positive 3 x-axis and negative minus 4 towards the y-axis. Okay. Now let us find out the length of OA and OB by the formula x2 minus x1 whole square plus y2 minus y1 whole square, the square root of that. Okay. So you can say that here OA is equal to OA is equal to uh, the length of this. Okay. So square root of x2 minus x1, that is minus 3 minus 0. It is minus 3 square only then. Okay. Minus 3 square plus y2 minus y1, that is minus 4 minus 0. It is minus 4 square. It is 3 square. It means that 9 plus 16, which is square root of 25. Okay. And that is equal to 5. Understood this? Now similarly, we should be getting OB is equal to also 5 units only, because it is the same coordinate points with different signs. Okay. So 3 minus 0, which is again 3 square. Okay. Plus minus 4 minus 0, which is minus 4 square. Okay. Which is also 9 plus 16, and that is square root of 25, 5 units. Okay. And by the coordinate points A and B, they are in the third and fourth quadrant. You can write them. Okay. And A, B are in third and fourth quadrants. Okay. Third and fourth quadrants. You can write that. So this is the solution for this problem. Okay. Understood? Okay. Now let us quickly move to the next problem. Okay. Now the problem number 9 is given with a table. Okay. And it is saying that the following table shows the coordinate points S, M, T. Okay. So there are points S, M and T. We have to find in each case whether M is midpoint of the segment ST or not. Midpoint formula. It is based on the midpoint formula. I don't remember whether you have studied this midpoint formula to find out the midpoint of a segment, line segment. Okay. Now I will simply explain you. Okay. And there is an additional question also here. We have to identify when M is the midpoint of ST. Can you find the find any connection between the coordinates of M, S and T? What is the connection? Okay. I'll tell you the connection only here. So to find out the midpoint of any line, okay, now for example, suppose this is a line, okay, and S and T are the two points, okay, coordinate points, S and T. Listen to me carefully. It's a simple explanation. S and T. ST is a line segment. I have to find whether M is midpoint of this S and T or not. Exactly falling here. So it means that half of this, half of this. Okay. It will divide that into two equal parts. It means that. Okay. Now assume that the coordinates of this is 2 and 3. Okay. And the coordinates of this are 6 and 7. So let us find the midpoint of 6 and 2 and 3 and 7. Okay, now how do I find out the midpoint of that exact half of 2, 6? It is 2 plus 6 divided by 2. Okay, it is like this. 2 plus 6 divided by 2 will actually give me the midpoint of x coordinate. Okay, what is that? 2 plus 6, that is 8 by 2, which will be 4. You see that? 2, 4, 6. 4 is exactly in the midpoint of 2 and 6. It means that. Okay. So similarly, 3 plus 7 divided by 2. 3 plus 7 divided by 2 is 10 by 2, which is 5. So if you find out the midpoint between 3 and 7, what will be the midpoint of this? What will be the midpoint of this? It is 5 only, because there is 4 here and that is 6 here. So 5 exactly comes in the midpoint of 3 and 7. Simple calculation I'm telling you. Okay. So how do you find out 5? Is by adding 3 and 7 divided by 2. is it not? So this is 4 5. So when you get the coordinates 4 5 for 2 3 and 6 7, you can say that M is midpoint of this S and T. Okay, so with this calculation only we have to fill this table. I will give you the generic formula for this. Okay, so when M is midpoint of S and T, that is the formula, that is connection that I'm just telling you here. Okay, so the connection that what they are talking about is midpoint formula. Okay, midpoint formula, listen to me carefully. Midpoint of uh, S with x1 y1, okay, and T with x2 y2, with x2 y2. You need to remember this formula. What is the midpoint of that? Is average of x coordinate divided and average of y coordinate. It means that only. Okay, so it is always the x coordinate sum divided by 2 and the y coordinate sum divided by 2. We need to make use of this formula only to find out the midpoint between the any two given coordinates. Understood this? Okay, now let us make use of this formula and fill this table and identify whether this given M is midpoint of these 2 points or not. Okay, it's simple that we have to make use of this as x1 y1 and this as x2 y2 and find out whether we are going to get these coordinates by applying this formula. That's all we are going to do. Understood this? Okay, now let us do one by one. See, minus 3 0 and 3 0 are the 2 points. Okay, now let us take that first point. First point is, it is minus 3 0, minus 3 0 and 3 0 are the 2 points, and we have to find out the midpoint of that. Understood? This as one point and this as another point. Find out the midpoint of that. Okay, so midpoint is equal to, midpoint is equal to, how do I do that? X1 plus x2, that is minus 3 plus 3 divided by 2, okay, comma 0 plus 0 divided by 2, 0 plus 0 divided by 2, that is y1 plus y2. So what is minus 3 plus 3? Got cancelled. It is 0 by 2, 0 by 2. So what is that? 0 0. So we got this coordinate as 0 0 only. So the first one is correct. So we can say yes. We can say yes here because we have 0 0, which is midpoint of these two given points. Understood? This is the simple one. And what is the reason for our answer is with midpoint formula. I can say midpoint is midpoint is 0 0 only. Midpoint is 0 0 only with formula. I can say with formula. With formula. There is no space here. You can just make some space and write that. With formula, you can say this formula. Okay, you can write the whole thing over there. Okay, now let us check for 2 3 4 5. Okay, and identify whether we are going to get 3 4 or not. Okay, so second one is 2 3 and 4 5. Okay, now similarly I will write this as midpoint. This is midpoint, and midpoint is equal to 2 plus 4, 2 plus 4 divided by 2, comma 3 plus 5 divided by 2. Okay, 3 plus 5 divided by 2. And what is this? What is this? 2 plus 4, 6 by 2, which is 3, and 3 plus 5, 8 by 2, which is 4. Okay, so is it 3 4? Midpoint given 3 4. Yes, so it is also yes, and the reason is same. Reason is same. With the midpoint formula we are going to get this only. Now similarly 0 0 0 minus 10. Okay, next one. 0, 0 and 0 minus 10. Simply apply that. Okay. Midpoint is equal to 0 plus 0 divided by 2. We are going to get that as 0 only first coordinate. Second is 0 minus 10 divided by 2. Okay. Say, I can say 0 minus 10 divided by 2, which is minus 10 by 2, and it is equal to 0 minus 5. 0 minus 5. Is it 0 minus 5 given for the third problem? No, it is 0 plus 5. Okay. So you can say this is no. No to this. And why? Because midpoint is 0 minus 3. You can write midpoint is 0 minus 5, not plus 5, not plus 5. Similarly, minus 8 7, let me do that quickly. Minus 8 7, sorry, and what is the second point? I didn't see that. 6 minus 3, 6 minus 3. So quickly calculate the midpoint. Quickly calculate the midpoint. What is that? Midpoint is minus 8 plus 6. Sorry. Minus 8 plus 6 divided by 2, and 7 minus 3. 7 minus 3 divided by 2, which is equal to minus 2 by 2. Correct? Is 6 minus 8 is minus 2, right? Minus 2 by 2, and 7 minus 3, which is 4 by 2, and which is equal to minus 1 and 2. Correct? Whether it is minus 1, 2? No, it is 0 minus 2. Okay. What did we got is minus 1, 2. Okay. So now let us write similarly. It is also no, because the midpoint is minus 1 and 2. Okay, this is how we fill in this table. Okay, remember this midpoint formula, and this is the answer for this additional question also. When M is the midpoint of ST, then the connection between M and ST are these one. Okay, those are actually the average of the X coordinate and average of Y coordinate. You can write that as a connection between M and the segment ST. Understood this? Let us quickly move to the next problem. Okay. The next problem is, it is also based on the midpoint formula only. Use the connection you found to find the coordinates of B. Okay, the connection that what we found in the previous problem, using that same formula, we have to find the coordinates of B. Coordinates of B we have to find out. Given M, which is midpoint. M is the midpoint of A and B. Okay, so they have given the coordinate values of, listen to me carefully, the coordinate values of one coordinate, okay, and the midpoint coordinates. The segment's second edge they have not given. We have to find that. Okay, so here it is given. Here given is like this. Given is like this. Suppose this is a line segment A, B, okay, and M is midpoint of this. M is midpoint of this, and what is M already given? That is minus 7, 1. Okay, and what is A? A is 3 minus 4. Okay, and B we don't know. That's why they have generically given it as XY. So using the midpoint formula, we know that if M is midpoint, divided by 2 is the formula to find out the midpoint between A and B. Okay, now use the same formula. Here. It is x1, y1, and this is x2, y2. Okay, now use the same thing here. I can say, what is M? M is minus 7 and 1. What is x1? X1 is 3. What is x2? X2 is x. X2 is the x coordinate of the second point, right? Divided by 2, comma. What is y1? Y1 is minus 4. Y1 is minus 4 plus what is y2? Y2 is y divided by. So we have two equal coordinates minus 7 1 and 3 plus x divided by 2 minus 4 plus y divided by 2. So this coordinate value is equal to minus 7 and this coordinate value is equal to 1. They are both correspondingly equal. So therefore I can say 3 plus x divided by 2 is equal to minus 7. Okay, and I can say 3 plus x take 2 to that side, it will make it minus 7 into 2. Okay, so the division will become multiplication over there. So therefore x is equal to, it is minus 14 minus 3. Okay, minus 14. So take plus 3 to that side, it will make it minus 3. So what is x? X is equal to minus 17. Minus 17 is one value. Okay, similarly I can say minus 4 plus y divided by 2 is equal to 1. It is the y coordinate equality I am saying. Okay, so it is equal to minus 4 plus y is equal to 2, taking to that side will make it 2. Okay, so keep y here and take minus 4 to that side, it will make it 2 plus 4, that is 6. So therefore y is equal to 6. So what are the coordinates? What are the coordinates of b then? X and y. We found out the value of x and y. Okay, so finally I can say therefore the coordinates of b equal to x comma y is equal to, what is the x value? Minus 17 and minus 17 and 6. So this is the answer by using the midpoint formula. Hope you understood this. Let us see the next problem. Okay, now we have the formula, midpoint formula, and we need a trisection formula here. So it's okay, now it's already a lot of time we have spent on. So let us stop our discussion here only. There are totally 16 problems given as a end of chapter exercises. We will see the remaining problems from 11 to 16 in the next session. Okay, thank you.